Welcome to this new video. Today, I'd like to take a look at the criticisms leveled at JavaScript and try to understand why some people tend to criticize this language and say that JavaScript sucks. We're going to start from the least legitimate reasons to the most legitimate and also the most technical ones by exploring a little more how the language works. Reason number one is a rather classic one. It's a popular language. And since it's a popular language, there's a tendency to say, oh, well, I don't like it, so I'm expressing an opinion that's a little different from what people think. But there's another reason too, and it's quite simple. Because it's a popular language, it's easy enough to make memes that work well on the subject, whereas if you go for more specific languages, it's a little more complicated. Beyond that, there's a phrase that I really like, which is the following sentence, which says that there are two kinds of programming languages: the languages that people criticize and the languages that nobody uses. And I quite agree with this observation, in the sense that either you're going to have a language that's widely spread, with lots of developers who will use it, but also lots of developers who won't like it, or you're going to have a language that's going to be much more specific, with a community that is interested by it, and will like the approach and the philosophy of the language, and they will be less critical about it during what we call the honeymoon phase. With a more mainstream language, you're bound to have people who like it and people who don't. There's another reason that's a little more toxic, but which is a little more of a minority in my opinion, and that's that some developers, in the context of JavaScript, like to do what's called gatekeeping. In other words, for them, a good developer is one who struggles with complicated languages. And so they don't necessarily like JavaScript because it's a language that's easy to learn and that you can learn fairly quickly. So for them, people who use this language aren't real developers. As I say, it's an opinion shared by a minority, but it's one that can be encountered in some memes or some comments shared about JavaScript. Reason number two, and this is often an argument given by people who lack arguments, is the fact that JavaScript was created in 10 days. Indeed, JavaScript was created fairly quickly when browsers needed a scripting language. The thing is, it was created using the knowledge and research of everything that had existed before. So even if the creation was quick, it was quick because many other languages had been created before, and a lot of thought had gone into it. So the birth of the language took much longer than that. Beyond that, the creation of a language, its efficiency or its logic, isn't necessarily linked to the time you spend developing it. For me, a language is above all a matter of compromises. Do we choose to compile it or interpret it? Do we choose typing or not? What paradigm do you choose? So every time we make a choice, it's going to be a choice with benefits and drawbacks. In the end, when you design a language, it's impossible to have one that's perfect. Otherwise, we'd all be using that famous perfect language. A language will make choices in terms of functionalities that will be interesting in certain situations and less so in others. So it all depends on the problem we're trying to solve. So when people give this argument, it's often because they don't necessarily have any better arguments to give you to criticize the language. So now we're going to get into reasons that are, in my opinion, a little more legitimate. The first is the fact that JavaScript is a language that is forced on people. The problem is that when you're doing browser-side code, you have no choice but to use JavaScript, even if you come from another language. If, for example, I'm doing a backend with C#, PHP, or Java, when I find myself doing browser-side code, I have no choice. I'm forced into JavaScript. And that is a problem, because people who have experienced other languages tend to try to reuse the same development patterns they know with their favorite language. This was my case, for example. When I started learning JavaScript, I was doing a lot of PHP. So when I started JavaScript, I tried to code the way I was used to in PHP, with classes, inheritance, and object-oriented programming. But unfortunately, it didn't work at all, because JavaScript isn't a language that works as an object-oriented programming language. As a result, I found myself trying to fight the system. So unfortunately, there are a lot of people who will criticize JavaScript because they're forced to use it even if they don't necessarily have a specific affinity with it. And it's perfectly legitimate in that case, not to like it. Another criticism is that there are too many tools available today when it comes to JavaScript. It's especially true for front-end stuff. You have to install things like Webpack, Vite, and so on, and that can seem a bit complicated. So in itself, it's not a problem that's linked to JavaScript directly. It's linked to the fact that JavaScript has an unpredictable runtime, unlike other technologies. For example, if I'm working with Ruby, the advantage is that I know I'm going to have a code that will run on a specific version of Ruby. When I do PHP, I control the PHP version installed on my server. The problem with JavaScript is that, in the browser, you don't control the runtime. You don't know what the browser will actually support, what functionality it will or won't accept, and so it becomes an issue. The problem is that we don't want to code with the lowest common denominator in mind. When we still had Internet Explorer, we said to ourselves, I don't want to write JavaScript the old-fashioned way, just because there are a few users who use Internet Explorer. We solved this issue with tools. We said to ourselves, I'm going to code with modern JavaScript, and these tools will convert my code to make it work on older browsers. We created this situation ourselves. This situation isn't necessarily linked to the language itself. It's linked to the fact that, unlike other programming languages, we don't control the execution context. Today, however, this is becoming much simpler. Modern browsers support most functionalities, so there's less need for tools. And I think that in the long term, we may end up not needing tools at all. You can already do this for small scripts. You can use the module system, the modern syntax. You don't necessarily have to bother with tools. But once again, this isn't a problem with JavaScript. It's a problem linked to the platform we run JavaScript on, the browsers. When we talk about the abundance of tools, we also criticize the fact that JavaScript has too many modules. In JavaScript, we use a module manager called npm. And what people like to do is look at this graphic and say, look, on npm, there's an immeasurable number of modules. It's a real mess. First of all, you have to take into account the fact that browsers use JavaScript. So when you use npm, you're using it for Node.js, server-side JavaScript, but you're also using it for client-side JavaScript. So of course, that means we're going to have a wider ecosystem. The other thing is that naturally, as developers, we're in the habit of creating new technologies. For example, we use a library, we find bugs or things that don't fit, or the library doesn't suit us, so what we do is create a new version, and so on and so forth. It's the same reason why there are so many Linux distributions. It's always the same problem. So if there are lots of packages today, it's also because there are lots of developers. It's a logical consequence. Speaking of packages, we often have this meme that you may have come across, where we say that our modules file is heavier than black holes or any other matter in the universe. It's a meme that simply stems from the way Node module handled things. It's important to know that this meme isn't really up to date anymore, and I'm going to be a bit more technical to explain why we end up with this meme and why it's different from other languages. Let's take an example. You're working on a project and you need dependency A and a dependency B. Dependency. A needs dependency C in version 1.0, but B also needs dependency C in version 2.0. What npm used to do when you installed dependencies was to create the A folder. Then in folder A, we'd have a node module folder, which would contain A's dependencies. So here, C, and so on and so on. If you have dependencies of dependencies of dependencies, you would end up with a very deep folder tree. And we'll have the same thing for B. With B, a node module folder, subdependencies, and so on. You need to know that in recent versions, if your constraints are easy to satisfy, for example, if I ask for a version 1.0 and 1.1 for dependency C, when he creates the folder node module, it'll say to himself, what I can do, given the constraints you've given me, you're telling me that you'll accept anything that comes from C between 1.0 and 1.1. So I'm not going to create sub folders like I used to, and I'm going to flatten everything. So we'll have the A, C, and B dependencies at the same level. So the modern version of npm has less of a problem than before, where you had too much subfolders every time. Now it's going to try a little harder to hoist dependency at the root than it did in the past, and this prevents the issue of extremely heavy node module directory. But we may wonder, why didn't we have this problem with Composer and other systems? In PHP, for example, we take the same scenario. We install dependency A, it installs dependency C. Perfect. Then we ask our system to install dependency B. Dependency B uses the dependency C with the 2.0 version. With Composer, we then come to an error and our system won't allow us to install both A and B. It will tell us, no, it's impossible. There's an incompatibility between the version of C in A and the version of C in B. As a result, the installation is completely blocked. This is essentially due to the fact that in PHP, but also in other languages, classes are defined globally. So you can't have two classes with the same name. JavaScript works differently and doesn't have a problem with this. And so it creates this issue, which has a complete effect on the community. When PHP developers create libraries, they tend to have as few dependencies as possible, because every time they add a dependency, it can create conflicts later on. The other thing is that when they choose to have a dependency, they try to agree on a common dependency version. For example, if we take the case of many PHP libraries, they use the doctrine collection system. This collection system won't move much, because if it does, it will break the whole ecosystem. So again, it's a matter of compromises. Either you have the JavaScript approach, which is cool because each library can manage its dependencies individually without the risk of conflicts. The disadvantage is that it duplicates the sub-dependencies and it can create more bloat. The advantage being that there are fewer installation constraints. Or you can use an approach like Composer or RubyGems, which allows you to have a slightly flatter structure, but the disadvantage is that you can't have sub-dependencies that have different versions. As a result, this can quickly become a bottleneck, and you have to ensure that the whole ecosystem evolves at the same speed, which isn't guaranteed. So when you criticize NPM, you have to be careful to understand what alternatives you could have and the compromises you'd have to make if you wanted those alternatives. Another criticism of the JavaScript ecosystem is the accidents that have occurred, such as the left pad incident. For those who haven't heard of it, for a while, many libraries used leftpad, a small function that added characters to the beginning of a string. You'd say, for example, I want this string to have a length of 3 characters, and it would add characters at the beginning of the string. This was useful, for example, for putting zeros in front of numbers. This library was used by many libraries. What happened was that leftpad was discontinued at some point and removed from NPM. As a result, many libraries broke and were no longer working because of this removal. In my opinion, this is not a JavaScript issue. It's a problem with the ecosystem, and it's always the same issue, whatever the language is. It's up to you to decide whether you want to use a lot of dependencies or none at all. As a general rule, when you try to install a library, look at the dependencies of that library. Don't take libraries that depend on 3 million things, because that means you're potentially going to have that kind of problem. And that in itself is something that could really happen in any other ecosystems. I know a lot of people tend to talk about JavaScript because that's where it happened, but we've had other problems in other ecosystems too, so it's not inherent to JavaScript here. Another solution is, for simple things, to not use libraries. If your code needs a little utility function, you can rewrite it, you can code it yourself. Don't use an external dependency for something so small that could potentially break or could change its signature. It's up to you to think carefully about how you want to organize things, but you must assume the consequences of your technical choices. It's not necessarily the ecosystem's fault here. There's another point. In JavaScript, people tend to say there are too many libraries. It's a feeling share most frequently for the front end, but it also happens for the back end with ORM or template engines. Again, it's a problem that we also have in other ecosystems. But in the context of JavaScript, there's also a problem in terms of users. In other words, today's JavaScript developers tend to jump on the hype train of any new framework or library. They see a new framework that promises better performance and poof, they jump on it and start using it and then complain that there's too much libraries. If you're tired of jumping from one framework to another, it's up to you not to jump straight on the new things that come out. Generally speaking, you have to understand that when a new technology is released, it's released because the person who developed it has a new approach and tries to tackle the problem in a different way. This library will be successful or people will talk about it, but it can also give other people ideas. So it's interesting that there are so many libraries because it means there are lots of different approaches of the problem. And at the end of the day, it helps the whole ecosystem to move forward. This doesn't necessarily mean that you have to switch to the newest framework. It's a bit like concept cars or proofs of concept. In the automotive industry, we've created cars that are absolutely useless for people, but they allow us to test things, to go into terrain that we're not necessarily used to, so that we can then improve the more classic cars. It's the same with new frameworks. They allow us to explore new approaches that can then be shared with others and may be integrated in your framework of choice. In the end, it's not that different from other ecosystems. You have to be careful about what you do and what you use. But let's get back to the language and the criticisms leveled specifically at JavaScript. One criticism you're going to see is the asynchronous nature of callbacks, which means that in JavaScript you're going to be using functions all the time, and that's hellish. If someone gives you this criticism, you can be sure it's someone who hasn't been writing JavaScript for quite a long time. Because this is an issue that has been solved with a new feature in the language, promises, and the ability to create asynchronous functions. Today we can use await and async to write this kind of code, which will streamline the code and will avoid callbacks as much as possible. The same applies to loops. Today JavaScript can loop other values with the for operator, and we can even use loops with asynchronous functions. What happens here is that I read the list of files in a folder, and then I read each file individually, waiting for the first file to be read before moving on to the next. But I can do things differently by reading all the files at the same time, using a promise.all method. There are lots of ways of organizing things, and you don't necessarily have to use functions all over the place to do it. So if people give you this criticism, it's often because they haven't really been up to date with what's going on in JavaScript today. Another problem is that the language is rather inconsistent with examples that are more or less legitimate. Typically, for example, if I add two arrays together, I get a string. If I add an array to an object, I get an object. But if I reverse it, if I add an object to an array, I get 0. And you could say that the language is a bit weird. And that's perfectly normal because when you do additions or equality tests, without using triple equals, there's coercion. JavaScript is going to try to interpret variables in a certain way, and that always leads to unexpected behavior. In the real world, it's a problem you're really not going to have. Because if you do these kind of operation, it's already a problem. Yes, we'd like an error instead of a return for mismatching type, but these are operations you're not going to do in real code. Even so, there are a few things that are a bit specific and more annoying. For example, if you're making an integer table and you're trying to sort it, it's going to sort it alphabetically. It's going to put 1, 10, 3. It's unexpected. Similarly, if you take an array and try to map and do parseInt on each item, rather than having 1, 2, 3, you're going to have 1, not a number, because parseInt can take 2 parameters. So there are lots of things like that are a bit peculiar, but if you've explored a lot of languages, all languages have weird behaviors. And it's only by learning and reading the documentation that you'll be able to unravel the subtleties and peculiarities. But this is no exception to JavaScript. Many languages have some level of weirdness, and specifically coming from PHP, it's something I'm used to working with. Speaking of unexpected things, there's also the fact that JavaScript isn't typed. And that's a real issue when organization code and avoiding bugs, because you don't really know what you've got at any given time. You're writing code that isn't necessarily super strong. But in this case, the community agree with this problem and has tried to find a solution. So there have been several attempts at fixing JavaScript with tools to add typing. Today there seems to be consensus around TypeScript. TypeScript has managed to convince quite a few people and allows typing to be added to JavaScript. This typing is only done at compile time. In other words, we're going to write types to help us understand our functions a little better and ensure that everything fit together properly. However, we're going to have to compile this code. This will result in JavaScript code. The transpilation is pretty simple since it just removed the types added in TypeScript to get valid JavaScript code. Then, this code can be executed. This means that it won't check that your types work at runtime. It's not the perfect solution, but it's already something that allows you to work better with JavaScript. If you really want an end-to-end typed language, then maybe try exploring another server-side language, since on the server you can choose the technology you want to use. If you really want typing, don't go with JavaScript. Go with a language that better fits your needs. But if you want to stick with JavaScript, you can choose to use TypeScript to help you writing safer code. It's a widely spread technology that you'll encounter in a professional environment. It's a choice that convinced a large part of the community. Another problem linked to the absence of type is dependency injection. In PHP, for instance, and in many other programming languages, when you create a class or a function, you can specify that it will have a dependency with a specific type, then the language can use reflection to analyze the code and manage the injection on its own. We can do this because our languages have typing, and we can solve this kind of problem to understand how to inject the dependency. Unfortunately, we don't have typing in JavaScript, so it's not possible to have an automatic dependency injection system. But with TypeScript, some people are able to exploit the compiler to solve this issue. For example, the Nest.js framework manages to do this with an injectable system. You can declare a service with a decorator, then this service will be automatically injected by Nest when it detects this type. It's something specific to this framework, but it proves that such an injection system is possible. There are other frameworks that take a slightly more, let's say, JavaScript-friendly approach, such as Adonis. What Adonis does is when you import, rather than importing the module directly from a specific folder, you import it from a namespace they call IOC, and it will import the module using dependency injection resolution instead of just loading the JavaScript file. It allows you to do the same thing, while keeping the possibility of mocking for testing environment. So again, what you want to avoid is trying to apply the pattern learnt in a different language, telling yourself, oh well, I want the same dependency injection system as the one I know in my language of choice. You'll realize fast enough that with JavaScript, since the language works differently, you'll have to find other ways to solve problems. And that's the main difficulty, rewiring our way to see problems. If you have started with another language, you'll have a tendency to do analogies, and it will slow you down. Another problem is that JavaScript works on a single thread. Now you might say, yes, but many languages work like that. Python does, PHP and Ruby do. Why is this a problem? Well, you have to understand that the problem with JavaScript is that it adds this notion of asynchronicity, but doesn't handle it as you'd expect. Let's take an example. Let's imagine I have a function that's a little slow, and I want to use it on several elements. By default, I could write this code. This code is completely synchronous, meaning that when my slow function is executed, it will block. And during this time, we won't be able to do anything else. Our script will remain blocked. In comparison, if we take a language like Golang uses the goroutine system, and we'll be able to tell it, you're going to create a sort of mini thread for the slow function. So, in a single process, for executing our code, we'll be able to ask it to do things in parallel. And that's not bad for CPU-intensive functions. In the case of JavaScript, we have the asynchronous loop system, which enables us to perform certain processing operations in the background, notably all read-write operations. So as soon as we need to communicate with the system, what JavaScript will do is hand over to another operation, continue to execute the rest of the code, process other requests and that sort of thing, and when it retrieves the response, it can continue. The disadvantage of this approach is that you'll end up having to use asynchronous code everywhere to avoid blocking code. For example, as soon as I need to make an SQL query, I'll have to use await. As soon as I need to read a file, I'll have to use await. As soon as I want to re-execute the query, I use await. And then this function, since it uses awaits, become asynchronous. And eventually everything will become asynchronous with this event loop system. The problem is that sometimes it's not necessarily that efficient, because you're going to spend your time communicating between the loop and your main process. This can be a bit cumbersome in certain situations, where a multi-threaded approach would be much more appropriate. So, once again, the problem is this. People are desperate to find a tool that will suit every need, and they want to use JavaScript in every situation. If you have a project with CPU-intensive operations, then you'll have to use a language that's better suited for this need. You always need to analyze the strengths and weaknesses of the language to be able to use the right tool for the job, and not simply to blindly adopt a language for the hype surrounding it. At the end of the day, being critical is important. It's important to question the technical choices you make, the languages and technologies you use. On the other hand, it's important to do so while understanding what you're saying and doing. Unfortunately, on the internet and social networks, it's very easy to get likes posting things that make people react. The problem is that when people are learning, they often tend to read these arguments and take them at face value. If you ever meet someone who criticizes a language or technology, ask them why they don't like the technology. The important thing is to understand why a technology may not be right for you or your problem. For example, someone might say, I tried to do this kind of project with this specific problem. We used JavaScript for that and we ran into this issue. That's what's really important, because this is this kind of experience that gives you the ability to make technical choices, to make them with a full understanding of the facts rather than basing your choice on a feeling. If you have someone who can't explain why he doesn't like a language, you can be sure it's just someone who's read an opinion somewhere on the internet and he is repeating it without having a good understanding of what he is talking about. So be really critical when you read opinion on the internet. Even if I've said some things in this video, do not hesitate to question them. And do your own research to better understand what I've said, and if you disagree too, you can express yourself, and that's important. Don't blindly rely on what someone else has said, whether it's me or someone else, obviously. I hope you enjoyed this video, and I'll see you in a future one.